Remember that an indifference curve is a set of all combinations of products that provide the consumer with the same level of total utility. Since utility is the satisfaction or benefit that a person derives from consuming the bundle of goods and services, the shape captures the individual's preferences. There are a few general characteristics that we want to consider. First, as we previously discussed, we will assume that both products are good, meaning more is always better. If both products are beneficial, then if we lose some Pop-Tarts, we need some amount of granola to keep total utility constant. When this is true, the indifference curve will be downward sloping, and we'll talk briefly about one way to relax this assumption later. Secondly, indifference curves can never cross. That would mean that at a single point there are two different levels of utility, because each indifference curve represents all the bundles that provide the same total utility. This cannot logically be true. Indifference curves are convex to the origin, meaning that they bow inward towards the origin, like this graph. Think about what this says about the products and their relationship to one another. When the curve is convex, that means the marginal rate of substitution is changing. Remember that the marginal rate of substitution is the rate that the person will give up one good for a gain in the other. In our example, it will be the amount of granola that a person gives up for more Pop-Tarts while keeping total utility constant. The upper left part of the curve is where the person is willing to give up a lot of granola for just a few Pop-Tarts. However, the bottom right curve is where the person is willing to give up very little granola for a lot of Pop-Tarts. Why is the person willing to trade different amounts of granola for Pop-Tarts? The key here is the allocation between the two goods is different in the two regions. Notice, in the upper left, the person already has a lot of granola and not many Pop-Tarts. But in the bottom right area, the person has a lot of Pop-Tarts and not much granola. Previously, we talked about marginal utility, that extra benefit derived from consuming one more unit, and that marginal utility is getting smaller as consumption increases. The concept of diminishing marginal utility. When a person has a lot of granola and few Pop-Tarts, the last unit of granola did not add very much to total utility, but a little more Pop-Tart would give a lot of utility. And that changes as we move down into the right. At the bottom right, the person has very little granola, but a lot of Pop-Tarts. This is the exact opposite situation. That last Pop-Tart did not add very much utility, so the person would be willing to give up a lot of Pop-Tarts for just a little bit of granola. You will notice that as we include the concept of diminishing marginal utility, that the slope of the indifference curve tells us about the utility the person derives from the two goods. This not only gives us a convex indifference curve, but it also means the slope tells us about the individual's preferences for one good compared to the other. A very steep indifference curve indicates that the person has a stronger preference for the product on the horizontal axis, Pop-Tarts. Pause the video and see if you can explain why that is. It is all about the slope again. The person is willing to give up a lot of the vertical y-axis good, granola, for a little bit more of the horizontal x-axis good, Pop-Tarts. A very flat indifference curve indicates that the person has a stronger preference for the product on the vertical axis, granola. The same reason is the same as before. The person likes granola, and so the consumer will give up a lot of Pop-Tarts for just a little bit more granola. So we've seen that the slope is an indicator of preferences. One more benefit of an indifference curve is that it can tell us about the relationship between the products. Two important ways that goods can be related are as substitutes or as complements. When a good is a perfect substitute, that means that a consumer does not care which product is consumed and will trade off between the products at a constant rate. For example, most people do not care which type of gasoline they put in the car. 1 gallon of 87 octane gas from Mobil is exactly the same as 87 octane gas from Shell. When this is the case, the indifference curve will be a straight line. A second type of relationship is when goods are complements. Complements are goods that are used together, like peanut butter and jelly, salad and salad dressing, and perfect complements are goods that are used in specific proportions. An example of perfect complements are flour and eggs when baking. Here's my grandmother's recipe for Paris puffins. Delicious, small little muffins coated in cinnamon and sugar. Notice that the recipe calls for 1 egg and 1.5 cups of flour, and this makes 12 muffins. If you open the refrigerator and have 2 eggs and 1.5 cups of flour, you could still only make 12 muffins. But if you have 2 eggs and 3 cups flour, you can make 24 muffins. Or if you have 1.5 eggs and 2.25 cups flour, you can make 18 muffins. In this case, the indifference curves are L-shaped. That's a lot of information, but it helps to think about some products that you consume. Think about 2 snacks you like, maybe Dove chocolates and pistachio nuts, maybe tortilla chips and salsa and potato chips. Now consider what your indifference curves would look like for these 2 goods. It's important to recognize that the indifference curve encapsulates the individual's preferences. So it's important to spend some time thinking about the model and what it tells us.